We're given the interval from 1 to 31, and g of x, g prime of x, and g double prime of x are all positive. So we want to see which of the following is false about the integral. Okay, so first, because g prime is positive, that means it is increasing. So we know that g is increasing. G double prime is positive, means that g is concave up. Okay. But now we have to consider the function x times g of x. So let's just call that f of x. What can we say about f prime of x? Well, in order to find f prime of x, we have to take the derivative of x times g of x. So we have to use the product rule. The derivative of x is 1 times g of x. And then we're going to take the derivative of g of x times x. Now, if we consider the interval from 1 to 31, we know that g of x is positive. X is positive because it's from 1 to 31. And g prime is also positive from the given. So we know that f prime of x is also positive in this interval. Now let's consider the second derivative. So we're going to take the derivative of g of x, which is g prime of x, and then we want to take the derivative of x times g prime of x. Well, the derivative of x is 1, and then we're going to multiply that by g prime of x, plus we're going to take the derivative of g prime of x and multiply it by x. So that would be x times g double prime of x. So I can simplify this further as 2 times g prime of x plus x times g double prime of x. And this is my second derivative. We know that g prime and x and g double prime are all positive, so the second derivative is also positive. So not only is g increasing and concave up, so is f. So just to get a rough idea what this looks like, from 1 to 31, it's concave up and increasing. So something like this is good enough. Okay, let's go back to the question. We want to see which of these is false about the integral. Any left endpoint approximation is less than r. Well, if we were to do left point approximation, so we would always pick the left-hand points. And we know that the left-hand points are always smaller than the right-hand points because the function is increasing. So it will look something like this. So yeah, this is definitely true. So A is true. Now let's continue with part B. We have R is equal to 30c times g of c for some c in the interval. So for this one, we have to use the average value. So let's say the average value is 1 over the difference of the intervals, so the difference of the endpoints, times the integral from a to b of f of x dx. So in our case, the interval was between 1 and 31. So we're going to replace a with 1, b with 31. So that would be 1 over 31 minus 1, which is 30. And then the integral from 1 to 31. F of x was defined to be x times g of x. So f of c, you just plug in c for x. That's c times g of c. And all we have to do is just multiply both sides by 30 to get 30 times c times g of c is equal to the integral from 1 to 31 x times g of x. And actually, this was defined to be as r, this whole integral. So r is then 30c times g of c. And if we go up, that's exactly what b is. So b is true. Now let's look at part C. We're given r is less than 930 times g of 31. And for that, we have to look at this picture here. we know that g of x is increasing, so the maximum value has to occur at this endpoint, which is g of 31. And if I were to draw a rectangle, let's say with height g of 31, so it looks something like this, the base would be length 30, right? So this will be from 1 to 31, which is length 30. The height will be g of 31. This total area then would just be 30 times g of 31. And we know this is definitely greater than r. R being the actual area. So r is actually this thing. Because 30 times g of 31 also includes this area. So clearly it's greater. And we know that this is greater than r. So if I multiply 30 with 31, so if I do 30 times 31, that's 930. Well, 930 times g of 31 will also be greater than r. Okay, so keep that in mind. If we go back to C, that's what it says. 930 times g of 31 is greater than r. So this is also true. Okay, now D. Any trapezoid approximation is greater than r. Well, let's redraw what our graph looks like, roughly. So it's concave up, and it's increasing from 1 to 31. If I were to do a trapezoid, I would use these two heights. Say, pick another one, let's say over here. We know that because it's not a good picture, we know that the height would be greater than the actual area. It'll be like the line between will be greater than the curve. So let's say if I pick some point here, you see when I connect it, it's going to be on top of that curve. And then same thing here. It's not a great picture, but it's always going to be above. So my trapezoid is always going to be above the curve. So therefore the trapezoidal sum is greater than r, than the actual area. So we have 4 true, so we expect E to be false. And let's see why it is false. Okay, we're given the integral from 2 to 32, x minus 1 times g of x minus 1. Well, if I do a u substitution, if I let u equal x minus 1, that means x minus 1 is u, and g of x minus 1 is just g of u. Now du is just dx. So I'm just going to replace dx with du. We know that these limits are in terms of x. So if I plug it into this substitution, when x is 2, u is 2 minus 1, which is 1. When x is 32, u is 32 minus 1, and that's 31. Notice this is exactly the same thing as the integral from 1 to 31 of x times g of x. So these should be equal. E says they're not. It says that this integral is greater, which is false. So E is our answer.